Okay, this is the Algebra 2 third quarter exam review. Let's see, third quarter. So we're going to start with some absolute value. Remember that the parent graph for absolute value makes like a V shape. So you have points like this, and they get transformed. So in this function, your vertex is shifting right 5 and up 3. So the vertex was at the origin 0, 0, and you want to go right 5 and up 3 and make your new vertex. Now normally the function would go over 1 and up 1, over 1 and up 1 on each side, but there's a stretch of 2. So it's going to go over 1 and up 2 on both the right and on the left. Okay, and then this function has a vertex, and then it continues to positive infinity on both the left and on the right. Alright, now this is actually a greater than or equal to. So the equal to part is the fact that this graph is solid and not dashed. If it was greater than or less than and it did not have an equal to on it, then my V-shape would have been dashed. Greater than means that the y values are greater than this V-shape. So from the V-shape, you could literally take your pen and go straight up. These values are greater than your V-shape. So you end up coloring, in this case, you color inside the V. Greater than your graph. And remember that these keep going up as your V-shape goes up. Alright, next one. We need to solve an inequality. And we're going to start by isolating the absolute value. So to get the absolute value by itself, first you need to subtract the 5. Alright, and then to get rid of the 1/2, you're going to multiply by the reciprocal, so you're going to multiply by 2. That will cancel that out. So now I have the absolute value of x minus 3 is greater than or equal to 2. So remember that great or means that it's going to be one or the other. It's going to either be x minus 3 is greater than or equal to 2, or x minus 3 is less than or equal to, and then you take the opposite of the 2, negative 2. So in both cases, you add 3 on both sides. And this gives you x is less than or equal to 1. And this one gives you x is greater than or equal to 5. So it's either less than or equal to 1 or greater than or equal to 5. So somewhere on here we need to, let's see, put 1 and 5. So let's say we put 0 here, and then this would be 1, 2, 3, 4, 5. Okay, less than or equal to 1, you use a solid dot because it could be equal to 1. And here's the less than part. Greater than or equal to 5, again, use a solid dot because it could equal 5. And then that's the greater than part. Alright, next one we need to factor. This is difficult to factor for 2 reasons. One reason is because you have both x and y. And the other reason is because your lead coefficient is a 5 and it's not 1. Factoring is much easier when it's 1x squared. Alright, so the method is you take the first coefficient times the last coefficient, so that's negative 60, and you're trying to find 2 numbers that multiply to give you negative 60 and add to give you 17. So I usually just make a list of numbers that multiply to negative 60 until I find the right pair. Negative 1 times 60, negative 2 times 30, negative 3 times 20, and I could keep going, but I found the pair that adds to 17. So you're going to take your 17xy and split it into two pieces, -3, and because this has an xy, you have an xy, and then 20xy. And then bring down the minus 12y squared, and bring down the 5x squared. Alright, so you want to think about this now in 2 halves, so cut it in half like that, and you want to take the greatest common factor of these two out. Well, 5 and 3 have nothing in common. They do both have an x, and only one of them has a y, so really all we can take out here is x. And when I divide this term by x, I get 5x, and when I divide this by x, I get -3y. Alright, 20 and 12 can both be divided by 4, so I'm going to write plus 4. Only one of the terms has an x, but they both have a y, so I'm going to take 4y out. 4y times 5x would give me 20xy, minus 4y times 3y would give me -12y squared. So the insides of my parentheses are right, which means that's one of the factors, 5x minus 3y. And then the second factor comes from the outside, x and plus 4y. Alright, in number 4, we need to remember your difference of cubes pattern. So the difference of cubes pattern is a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. Some teachers will tell you to remember this with SOPs, and if your teacher did tell you that, go ahead. Otherwise, it's not too hard to remember the pattern. It has one minus in it, and because this starts with a minus b, then this also starts with a minus b. Now I want to rewrite each of these as something cubed. So I do remember that 27 is the cube of 3. Okay, so 3 to the third is 3 times 3 times 3, which is 27. If you don't remember, and for example with 512, if you're just not sure what number cubed is that, you can take the number's cube root. So if I press math, and I go down to, let's see, this is number 4, I can do the cube root of 512. Oops, I went not quite right. Alright, and it's 8, so that means 8 times 8 times 8 would be 512. So 512 is the same as 8 to the third. So everywhere in your pattern where you see A, you're going to put 3x, and everywhere you see B, you're going to put 8. So I get 3x minus 8. That's this part right here. Then I need to square the 3x. Plus the 3x times the 8, plus, and then the square of 8. And then in your last step, you just simplify. So my final answer is 3x minus 8. When I square this, I get 9x squared. This becomes 24x. And then the last one is 8 squared. 8 times 8 is 64. Alright, we have another factoring problem next. This is one that we say is quadratic in form, meaning that you can factor it like a quadratic equation even though it's actually a quartic equation. So I'm still looking for numbers that multiply to -25 and add to 24. But because your lead coefficient is 1, once you find those numbers, you can just put them right into your factors. So -25 could be 1 times -25. That would give me -24. And then if I just switch the signs, I do -1 times 25, that's the pair of numbers that adds to 24. So that's the pair you want to use. And so your factors are going to be minus 1 and plus 25. Now normally we would have x minus 1 and x plus 25, but we need to get up to x to the 4th. So what you're going to do is make this x squared and make this x squared. So x squared times x squared is x to the 4th. And if you multiply this with FOIL, you will find that your middle term is also 24x squared. So just when you think you're done, you notice I have a difference of squares here. Remember that the pattern for difference of squares is a squared minus b squared equals a minus b times a plus b. Now we are going to use that to factor x squared minus 1. We do not need to use that for x squared plus 25 because there is no pattern for the sum of squares. Alright, so the square root of x squared is x, and the square root of 1 is 1, so I have x minus 1, x plus 1. And then bring this one down, x squared plus 25. Alright, and now we have some complex numbers that we need to combine. These two are being multiplied, and then this one is being subtracted. So for multiplying, you need to use FOIL. You're going to do first outer. So that gives me 15 plus 6i. Inner and last. So negative 35i minus 14i squared. Alright, then I need to distribute the subtraction to the 6 and to the minus 5i. So that gives me minus 6, and minus negative makes a plus 5i. Alright, so my real terms are 15 minus 6, so that gives me 9. I know that I squared is negative 1, so I can substitute negative 1 for I squared. So I have minus 14 times negative 1. And then my imaginary terms are 6i, negative 35i, and 5i. So 11 minus 35 would give you minus 24i. Alright, so 9 plus 14 is 23. And you want to bring down your negative 24i. Okay. Alright, in the next problem, you have to watch the directions because a lot of people will start simplifying the radical right away, but the directions say to convert to exponential form. So exponential form, the exponent is the power over the root. Alright, the cube root of 8 is just 2. So I'm just going to take that right away. And then I have x, power is 2, and root is 3. So x to the 2/3, y to the 12/3, and z to the 5/3. And then you want to simplify your y's. So you have 2x to the 2/3, and you have y to the 4th, z to the 5/3. Alright, in problem 8, I'm going to show you two methods, and there's actually a couple different methods you could use here, but most people I think like one of these two methods. Alright, the first method that I like is to find the biggest multiple of 4 that's less than 295. I think I'll work backwards from 300. 300 is a multiple of 4, and if I subtract 4 I get 296. So I need to subtract 4 again and get 292. So I could say that this equals I to the 292 times I to the 3. Now any multiple of 4, any I that's raised to a power that's a multiple of 4 is going to be 1, because I to the 4th is 1. So 1 is going to go away. I to the third, if you can't remember the first four i's, you can look at your calculator. The calculator for some reason won't do the large powers of I, but it will do the smaller ones. So you need to press your mode button and make sure in A plus BI mode. It's right here, so you need to highlight it and press enter. And then you can second quit, and you need to enter just I to the third. So the I is down here with the decimal. Press second, decimal, and you want to raise that to the third power, and you find it equals negative I. So if I have 1 times negative I, well, 1 times anything is itself, so your answer is negative I. Okay, let's go